Hi folks, today I bring a LCD driver, reference LC75805. We have already analyzed the driver with this reference installed in the association with another driver sharing the same LCD and same panel. This panel belongs to a Kenwood car radio model KDC708OR/RY. The diagrams are available on the web and help a lot with the panel connections. I highlight the LED present in the keys. They allow configuration for green or red colors. They also have a blue LED in the position of the button SRC key, and this LED is installed in series with both LEDs on the FM button. This means it will activate it in the color you select. Don't matter if it's green or red, the LED blue will be on. Because you have a total of the 408 segments, they are controlled by 4 buses of the 120 segments. This is a lot to proceed to the identification of the segments, and I have done a small function to allow the count and represent the number of each segment. Okay, I have button with a trigger is normal, and every time I press the button you see the segment go off. In this case this is the segment 1 is off. The segment 2, 3, 4, 5, 6, 7, 8, segment 9, and so on, okay? And every time you skip a digit, you know the number in the next digits is the number 2 plus 40, 42 in this small segment, okay? The matrix to represent digits is 5 by 7. As normal, every time I press the button to take the identification of the segments, I receive in the serial monitor of the IDE of the Arduino, the number of the segment, the block of the bit, if is the first byte or the second, the number of the bit inside of the byte, and so on, okay? This makes very easy the identification of the segments. This is the identification of the segments. The rule is very clear, and you can see here the segment number 2, segment 42, segment 82, segment 122, 162. This means each digit realizes a skip of 40 segments, okay? This is the wheels identification. I create a function to make the animation, and is easy to confirm the numbers present in schematics. Like I referred before, you have the manual of service in the web, and if you go to the page 14, you have the schematics of the panel, and you can see, for example, the button I refer as the SRC. The LED is in serial with both LEDs from the button FM. Also, you can check here in this position pin out to make the connection of the panel. You can find some pins, they are NC, not connected. You have the VDD, you have the dimmer, for example, to control the backlight of the panel, the data, reset, chip enable, clock, the ground of the illumination, pin 13, the plus 12 volts, in this case 14 is the pin to power up the LEDs. It's easy to identify the type of the connections. As normal, I try let the code so basic as possible. You can see, for example, here definition of the pin 8 as a data, 9 as a clock, 10 as a chip enable. The button 2 is a port used to trigger to make the identification of the segments, and so on. This is a very basic. Okay, don't have any library to be applied in the code. The implementation of the trigger button, and I like the stack here, the activation of the LED green or red in the panel. As you can see here, this is a command, this is a format to send a command to the driver, and you can see here the count of the bit 1 to 8 in the first byte, the second byte 9 to 16, and the bit number 9 is forced to 1 to activate a color of the LED in the panel. This is LED green, and if you see in the function of the LED red, you can see is the bit number 8. Also, if you want to use the infrared receiver, you need to activate a pin. I don't remember if it is 7 or 10, but it is one pin, bit from these both bytes to activate the power up of the infrared receiver. Okay, the remaining code is so basic. I think it's not necessary to explain anything about this because it's very basic. Here I have commented the lines of the normal working because I all activated the search of the segments. But after you can comment these two lines and uncomment this.